Okay, the last part, this is Mr. Anderson for Statistics 130, and this is another little application of section 6.2, which talks about the applications of the normal distribution. Now, one of the fun parts is actually finding cut scores. You know, so let's say you want to set up a criteria for an entrance exam or maybe an advanced placement test, or, you know, you're just going to say, look, I want the top candidates. So I'm going to look for the cut score for the 90th percentile or the 80th percentile, or just say, what's the cut score for the 60th percentile? Now, the cut score for the 50th percentile is pretty easy, because the 50th percentile, remember, that's in the center of our data. So we're going to get to the 70th and 80th percentile somewhere over here, but remember that all is academic based on what our scale is. But the cool thing is that using this formula here, we can find cut scores by looking at x equals my z-score, so here's my z-score, times the standard deviation, and because of order of operations, those two will always get done first, and then plus your average. Doing these three things in succession will give you cut scores. So what I did is I just Googled ACT test scores and ACT averages, and I found, according to a 2001 study of the ACT, the average score was a 21 out of possible 36. And the standard deviation was 5. Now, I rounded that up. It was technically a high 4, but I thought, like, well, let's just make it 5 to be a little easier. So here's what I want to do, is I want to find the cut score for being in the top 90%. So if you want to say to yourself, man, I want to be in the top 90% of all the test takers who have taken the ACT, how am I going to do that? Well, first of all, let's get our formula written down. The cut score is going to be equal to the z-score times the standard deviation plus the average. Now, we can know this number, which is our standard deviation, multiply by that, and we also know our average, which is 21. But we don't know our z-score. We don't know what that is. But we do know what we're looking for. We're looking for somebody in the top 90%. So what we're going to do is we're going to go to the table, and we're going to look for the number that's closest to 90%. So get your book open to page 784 and 785, and let's just start looking at numbers. Now, you're not going to be able to see very accurately on this because there might be some pixelation as I upload this to the internet, but you'll notice that this value, 0.8997, and this value, 0.9015, that's the closest we get to 90%, that one and that one. And you want the closest one to 90% based on those tables. So, for example, I found a z-score that's 1.28, which was 0.8997, and I also found a z-score at 1.29, which was at 90% and 15, let's see, 10,000ths there. Which one was closer? Well, this one was 3 10,000ths away from the from 90%, and this was 15 10,000ths away from that that 90%. So we're going to go with 1.28. It's a little bit closer. So x equals 1.28 times 5 plus 21. Using our calculator, we're going to be able to find the values here for what would constitute the 90th percentile here. Kind of excited to see how I would stack up here, as I remember my score there. Blam! Looks like a 27.4 would put you in. That's your cut score for the 90th percentile, 27.4. Well, therefore, it looks like 28 is going to give you your 90th percentile there, since the ACT doesn't report back in decimals. So, wow, 28 is going to be your 90th percentile. That means anywhere between 28 to 36 is going to put you in the top 10% of all those who take the ACT, at least back in 2001. So, that's pretty astounding. Alright, so now what we're going to do is we're going to take a look at suppose you just want to feel better about yourself and want to say, well, let's look at the middle 50%. Well, so I want to know if I take half of all the test, I want to know the middle half. I don't want to know the top 25% or the bottom 25%. I just want to know what score would I need to be in the middle 50%. Well, first of all, let's imagine that the average is right in the center. And then if you want the middle 50%, you got to go up 25% and down 25%. So we're really looking at trying to find some z-scores between these two numbers here. So what I need is a z-score for my 75%, and I need a z-score for my 25%. I'm going to put 25% on my left and 75% on my right. Alright, so I want to find those z-scores. So let's write out our formulas just so we keep things in check here. Z times standard deviation plus average. Z times standard deviation plus average. Alright, separate those. Because what I'm going to do is when I find my upper and lower bound, I'm going to subtract the two and have my middle range right there. But really, I can tell myself what my higher and lower bound is. Alright, so our standard deviation plus our average stays the same in both problems. So what we're going to do is take a little side quest and take that little side quest to find our z-scores. And our z-scores, I first of all need to find 25%. So I'm going to look on page 784 for 25%. And 25% is right about, let's see, oh, it looks like I found it here. It's going to be, oh, I just had it. Hey, Rachel, how you doing?
It's all done.
Oh, okay, you can watch another show.
Okay.
I'll be right back. Love you, honey.
Love you too.
Thanks. So it looks like we're looking at negative 0.67. Let me find that there. There's negative 0.67 and negative 0.68. And it looks like, who's my winner here? Negative 0.67, negative 0.68. This is 2483, so that's 17 away. And negative 0.67, this is 0.2514. Looks like that's the winner. So negative 0.67 is my z-score for this one. All right, put my multiplication symbol there. Good. And now I'm going to go to my 75%. And by the way, do you think you know what that's going to be? This is going to be kind of interesting if you're a forward thinker, like, well, do I really need to check? Yeah, you probably should. Negative 0.6. Oh, huh. Let me see, to go into 75% here, it looks like my closest one is positive 0.67. Ah, the beauty of symmetry, folks. Positive 0.67, because we know that these normal distributions are symmetric. If I'm looking at the 25th percentile, and I'm looking at the 75th percentile, it would make sense that these would be the same z-scores away from the norm. Well, let's go do some calculations. I'm going to type in negative 0.67 times 5 plus 21. Blam! I got 17.65. And according to order of operations here, the calculator did that perfectly, multiplying first and then adding. And then we're going to go to the other one. I'm going to just delete the negative. It's the same problem without the negative. And that gives me 24.35. So, if you want to be in the middle 50% of all of the test takers, then you probably should shoot for an 18, because if you shot for a 17, then you would actually be outside of that area. And in this case, you would definitely want to shoot for a 25, even though rounding-wise you could consider that 24. 24 would put you into that 50% right there, but 25 would put you a little bit out of it. So, think about it this way. If you took the ACT back in 2001, or according to this data, if it's still valid, the middle 50% would be between 18 and 24, and the average would be a 21. So that is an application of finding cut scores on your normal distributions. So again, if you have any questions, just shoot me an email. Thanks a lot, and thanks for watching.